Hello everyone, today we'll be talking about the derivative. To recognize the meaning of the tangent of a curve at a point, calculate the slope of a tangent, identify the derivative as a limit of a difference quotient, and calculate the derivative given a function of a point. Describe velocity as a rate of change, and explain the difference between average velocity and instantaneous velocity. Recall from definition earlier that the slope of the tangent line, or by m tan definition, m tan, that was equal to the limit as h approaches 0 of the f of a plus h minus f of a all over h. Right? Provided the limit exists, and this a is our x value at a point that we're trying to investigate the function. So let's say, for example, find the slope of a tangent line f of x equals x squared. That's our function at x equals 3. So here we want to plug in our a equals 3, and so our m tan would be equal to the limit as h approaches 0 of 3 plus h, the f of 3 plus h minus f of 3 over all over h. Now what is the f of 3 plus h? That will be the limit as h approaches 0. F, our function is x squared, so we have to write in 3 plus h all squared minus 3 squared over h. And let's see what is happening as we continue working this down. 3 plus h squared is going to be 9 plus 6h plus h squared. Then minus 3 squared is going to be 9 over h. And keep the limit as we go along. Limit h approaches 0. This 9 cancels out this 9, so we end up with 6h plus h squared all over h. But then we can factor out this h. So keeping our limits, h approaches 0. We're ending up with limit as h approaches 0 of h, 6 plus h all over h. Now these two cancel, so we have limit h approaches 0 of 6 plus h, and that would just be equal to 6. Okay, so if you plug in h equals 0 here, that becomes 6, and 6 is our answer that we're looking for. All right, so that is our answer using our m tan approach. Now we can use this kind of idea to investigate the tangent line of this, which we're going to do a little bit later. But for now, what we want to do then is talk about the definition of the derivative. And the definition of the derivative, we're using the function form with f of x, and then what we will do then is that we will say this definition, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h, right? So what we do here is that we will calculate everything using their x plus h all the way down, and then plug in the x value, or the x equal a at the end, and we should end up with the exact same answer as if we did the m tan, but it's a different approach of a functional form, or pretty much the same. Very similar approach, but a little bit different is that instead of plugging in the 3 at the beginning, we plug in the 3 at the end, and we should get the same answer. Now let's use this to approach a different problem. Let's find f prime of x. F prime of x, where f of x is equal to x cubed minus x, and we plug this in through our almost f prime of x be equal to f of x plus h cubed, f of x plus h cubed, right? And then minus x, which is x plus h, right? And then minus our f of x, so it's this first. I want to put this in, right? Well, f of x plus h cubed, excuse me, f of x plus h cubed, just plug it in. F of x plus h cubed would be, let's put in our limits, h approaches 0, x plus h cubed, all cubed, minus x plus h, then all of this minus all of x cubed minus x, right? So this is our f of x, this is our f of x plus h cubed, all of this over h, and then let's see what happens. Let's expand out this x plus h cubed, so let's limit h approaches 0, and then we got x cubed plus 3x squared h plus h cubed, right? It should be plus another 3x h squared, and we'll get that if we just multiply all of that out, right? And then minus x minus h, taking those in, and then distributed in that minus x cubed plus x, right? And then we try to simplify all of this, and let's see what happens. And we could have done this aside. We'll do that aside maybe in a later time or another time. But we are going to continue taking limits as h approaches 0 of 3x squared h plus 3x h squared plus h cubed and minus h, right? Because this x cubed would drop out, and then there should be a minus x dropping out plus x, and so that's what we're left with, all of this over h, and then we can factor out an h, so that's the limit. H approaches 0, we factor out an h, we have 3x squared plus 3xh plus h squared minus 1, and that's all over h. So this is a limit, as h approaches 0 of, let's see what happens now, 3x squared plus 3xh plus h squared minus 1. And so this becomes equal to 3x squared minus 1. Right? That's what we expect. Okay, so that's how we use our definition of derivative to find a function, to find our derivative function. Now, if we were asked to find it at a particular point, like 3, then we'll just plug in the 3 right here.